In continuing my Chapter 8 problems, what I wanted to do for number 16, it happened to be a t-distribution, and I got to enter in some data, so that way I get to kill a few birds with one stone here. So what you're going to do is enter the data into your list 1. So you're going to hit Stat, and you're at Edit, so hit Enter and go to your list 1 and enter that data into list 1. And for my values here, and after reading the description, I chose the appropriate hypothesis test. They just wanted to know if it differed, so I said that the null was that it equals 100, and the alternative is that it's not 100. So now I'm going to have to go to my chart to get my t-values. Now I don't really need these t-values in order to calculate the test statistic, because I'm actually going to use stat t-test, and to get this value right here is of course much easier with my calculator. So I'm going to go to stat, and I'm going to go to t-test. T-test. And in t-test, I'm not going to hit stats like I normally do. I'm going to use the data, because I've entered that data into the list, and that data is going to calculate all the appropriate variables that I need for that. The only thing that I need to put in there is that my mu naught is, for this one, 100. They gave that to me in the problem. And I need to put in my appropriate hypothesis test, which is not equal to mu naught. And I'll get your chart so that you can get these values entered. I'll go ahead and get you your chart. My number of data points was, let's see, 12. So that means that my degree of freedom is going to be equal to 11. They wanted me to use a 0.005, no, 0.05, sorry, 0.05 as my, alright, alpha equals, I had to go look it up, 0.05. I'm going to take half of that, and half that would be at this 0.025 level, and here is my degree of freedom being 11, so I'm just going to plug that number in to the problem. Let's see, let me go get it. You can see that I plugged in the 2.201, both the positive and negative, and I already had that value. Then next, based on this, I wouldn't reject the null, and then for the B part, you're going to need this formula here, where this D equals E. You're not, and I'm looking for the difference here. You're going to need the difference. Mu over the standard deviation. So you're just looking at the difference in these two. And for mine, it was 95 minus 100. Take the absolute value of that because I'm just looking for the difference. And then that equals 0.67. So, and I'm just going to read this off the graph, so let me go get one of those for you. Alright, here's table A17. You won't be required to use this on your test, but it is worth going through because it is important to look at these curves and using your alpha and beta values, knowing what you want your error to be, figure out what your sample size is. Notice this is for alpha is 0.05. This is for alpha is 0.05 as well, but this is one-tailed, this is two-tailed, and our beta equals the 0.1, so I'm going to be looking at this 0.1 level. The alpha that they initially told me was the 0.05 two-tailed, so this is the one that I'm going to be looking at. My difference on here is 0.67. So it's basically with my beta equal to 0.1, my difference being the point, here's 0.6, here's 0.67. So it'll be right around in here somewhere, hitting this blue line. This blue line happens to be this one right here, which is the 29 degrees of freedom. And so then going back to my initial problem, with that 29 degrees of freedom, I would choose the n equal 30. On number 22, they try to help me out a little bit so that, but I can use my calculator. It's really not helpful when they give me the t value, the critical values, because I would really just as soon use my calculator to get these, but I'm going to use table A8 in order to get these p-values, although it's much easier with the calculator. But here we go, just table A8. Knowing that my n is 17, so my degree of freedom is 16, my t is 3.1. So here we go. Here's my table A8. Let's see. My degree of freedom is 16, so I'm going to scroll down. This is my 16 column. I'm scrolling down until I get to 3.1. And I get to 3.1. Let's see, right about there. So my p-value is 0.003. So there we have it. I've read through this, and I've noted that my p-value was 0.003. My alpha was 0.05, so the probability of this actually happening is 0.003, so it's a very small probability that this would actually happen. This says that if it's less than 5%, my alpha is 5% or 0.05, so if it's less than 5%, reject the null. I definitely am way less than 5%, so I reject the null on this one. Going to my next one, I'm going to do the exact same thing using my same table. I'm going to get my p-value. My n is 10, so there's my degree of freedom. My t is 1.6, so I'm going to have to scroll down until I get to 1.6. Hold up here. 1.6 is right in there. So there's my p-value for this number 22b. Let me go back. So we have keyed in our p-value, comparing it with this alpha value. Probability of this happening is 7.2%. Our alpha says if it's less than 1%, reject it. Well, it's way more than that, so we do not reject the null, and we say that we're fine on all this. Doing the next one, the reason I want to do the next one is because it is negative, so let me scroll down and get that and go get our chart. This one we have that n is 30, and we have that our t is negative 0.2. So n is 30, so my degree of freedom would be 29. 0.2 would be the 0.421, but it's negative, so in order to get that value, you're going to do 1 minus 0.421. And with that, you'll get 0.579, and then you will see, where are we at? There we are, the 0.579. Now we're comparing this value with some alpha, but the probability of this happening is about 57.9%. They didn't even bother giving me an alpha because we're going to go do not reject the null on this one. Alright, this particular problem, this A part is wrong, so if you'll just pick that answer, it'll count you as right. But what you really should be choosing is this one. This is actually the correct answer, but EWA is wrong here. And I know that they marked me as correct, but this is the actual right answer. I knew it was the right answer, but I just wanted it to be marked correct. And so I was like, what in the world are they asking for? So that is not right. But this is what you're going to be testing. And actually, if you go to key in the values, you will use the appropriate test, which is this one. And you will get the correct answers if you plug in for the right test. So you're going to go to Stat, and then you're going to go to Test. This is a Z-test and a hypothesis test. z-test. You're going to go to stats because, of course, we're entering in our statistics. The mu naught on this is 5. The standard deviation, 0.36. The x-bar, the sample mean, is 4.86. And we are using a less than mu naught test because we want to know if the number of milligrams or number of grains or something is less than what it's supposed to be. And when you do that, you'll get these values for Z and P. And we are doing, the probability of this happening is very, very small. I usually like to look at my p-value. He's my friendliest one. I don't even know what the significance level was, but I'm sure it wasn't. It was 0.01. So alpha was equal to 0.01. So they said if it's less than 1%, then you need to reject the null. Well, good grief, for way less than 1%, for the 0.00, whatever that number is. So we definitely reject the null, and they are not filling these things as they're supposed to.